Is going to
Hello, this is Ben.
Hey Ben,
Oh,
good
sorry,
afternoon.
sorry I'm late.
No
Good
worries,
morning.
we're just getting started. Good morning. Hey, so my Linux machine stopped working with Zoom, so doing this from my iPad. So ignore any notifications you see. Anyway, so we're talking about bucket sharing. Yeah. Okay. So I want to first define like what kind of sharing we want to enable. Let's first, I came up with the hypothetical scenario. Created three teams. Let's call one team as hello.
You got a bit of an echo.
Is everyone muted? Okay, it sounds better now. So let's define three teams. One is the photos team, one is the videos team, and let's say there's a profile team. Let's just assume in this scenario that the profile has both photos and videos. So the photos team would manage the photos, the videos team would manage the videos, and the profile team would need data from both. So in this scenario, let's define some users. In the photos team, there's Alice, who belongs to the group photos. And there's Bob in the videos team, who belongs to the group videos. And let's say Fu belongs to the profile team, and Fu would be a part of photos, videos, and profile groups. So these are access groups, not the Kubernetes API groups. Kubernetes lets you define this kind of hierarchy of access, including the groups part. So this model kind of makes sense, right? Like this is the kind of model we can support in terms of bucket. Like this is the kind of model I think we should support in terms of bucket sharing.
Sid, I want to caution you. I think I know where you're going with this. And like Kubernetes RBAC rules only extend insofar as like the ability to create and edit objects. Like once the object exists, it doesn't remember who created it. So like
I mean, we're talking about clustered resources. So if we put some metadata in there, and if someone edits it, it's considered, their fault. It's not a user doing it. We could.
Well, I mean, we should hear the rest of this proposal, but I mean, I just want to make sure that it's clear that like the RBAC system in Kubernetes executes when you're talking to the API server to do something, but then after the object is created, it forgets who did what, right? It's just an object now.
Why does it matter though?
Okay.
Right, I think it's fine for that purpose.
Yeah.
I mean, it's again we're saying that we're talking about creating bucket access, basically, right? That's the flow where we are looking for
Right.
controlling with access control or something.
Right.
Right, but remember that the way that we structure these things is you create an object, and then some RBAC runs that says yes, you were allowed to create that object, but then when it becomes time to bind a BAR to something, like a controller does that work. And the controller just sees a BAR. It doesn't know who made it, right? They're just, a BAR was successfully created by someone, and it has some values, and now you have to decide what to do with it.
And
yeah,
so you're saying that
the controller is running in, it has no idea who.
So Ben, that's not going to be a problem because yeah, I'll talk about how a bucket gets ownership or starts belonging to a group, and then we'll go from there.
Okay.
Yeah. So yeah, I see what you're saying. So let's go to this step. Let's say team one, that is photos team, creates bucket one, and team two, videos team, creates bucket two. Bucket one is created by Alice, and bucket two is created by Bob. So and Fu gets access to both. So in this case, first during the creation of the bucket, the group will be designated by the bucket class. So the bucket class should have some. I mean, this is one of the proposals. So we can figure out where the group comes from. but inside the bucket object, somehow we have a field that stores the bucket group.
Okay, so the proposal is when I create a bucket, I have to stamp on it the group that it came from, and I'm not allowed to lie about that because someone somewhere is going to enforce that the value matches reality.
No, I think it means that you can specify an allowed groups, right? Just like you could have specified an allowed namespaces, I think.
That would also work.
That's what I understand.
That would also work, yes.
So it's not about your permission. Sorry, I was meaning to add.
So for the buckets, the allowed list doesn't need to be verified against reality, but in order to enforce this, when the guy comes and creates a BAR, that will also need to have group information stamped on it, and that will have to be validated so you don't lie, right?
Yeah, that validation can be done easily through an admission controller.
But it's a weird thing to do, right? I just
no, it doesn't come in through the bucket access. It comes in through whoever creates the bucket access request.
Right. Yeah. The BAR. Someone when you create it,
who creates it?
You have the RBAC rule to create BARs in your own namespace always, right?
Right. You just take it, assume a role.
No. I'm saying we get that. We have a gate around it. We say that only if you have the permission to create a BAR for this bucket will it go through. We could do that.
Okay, so you're saying that BAR will not be created. I was thinking BAR should be created, but BA wouldn't. Just, we don't bind to it anything, and it stays rejected, and that's it. You can always create.
Yeah.
The namespace object is a request, right? And it can get it. It should be created by the user who requests, and then the controller who is responsible to answer.
Go on.
The controller that tries to answer that and create a BA, that's the one that actually, gives away the permission, right? Or needs to verify. That's where we need to verify, I guess.
And in order for that thing to do that, the BAR would have to have stamped on it somewhere the user or the group of the one who created it. With at
least that.
I don't think it's a. You don't need to stamp it, maybe, but you note which namespace it resolves to, right? And inside that namespace, it can just specify, well, I want you to assume I am this service account or whatever, right? If that's the
that can be done. So service account mechanism. Sorry, go ahead.
How do you map from a namespace back to a user or account or a group? I don't understand how you do that mapping. If you start from a namespace, there could be lots of service accounts and lots of users, lots of groups. Like how do you know which one?
But the BR can specify, right?
Right. But that's the stamping I was talking about is when I create a BAR, I could put a user and group on it, but then I could also lie about the user and group. So something we need to validate that.
That we can do.
But this starts to feel very.
Are we
weird,
trying
right?
to really have clear, access control inside the namespace, or is it mostly access separation inside namespaces? Because I thought that we're not really trying to say like restrict access inside the namespace, because anybody can basically see anything right around there. But we're talking about the fact that we're not giving out the workload who's like running inside the pod access if we're not meaning to do so, and so we have separation.
Saying that there's some users that belong to groups that can get access to other namespaces objects. Like I guess groups can span namespaces. So the idea is by being a member of a group,
they can request it.
I gain access to more than just my namespace in theory. But I don't.
But that's coming from external like object storage. That's you're right. You're getting access to something, but eventually, from Kubernetes point of view, you create a BAR, which is a request for, a BA basically, and you get allocated a BA. And from Kubernetes perspective, you're not really accessing anything, really.
Just talking about Kubernetes, it doesn't seem like namespace is the right boundary.
Namespaces are kind of all you have. I mean, I see what you're trying to do with the users and their groups, but it feels like a misuse of the Kubernetes RBAC system, because the users and groups are meant for like controlling whether you can interact with the API server in a certain way, but we're not interacting with the API server. We're interacting with a controller, and the controller doesn't know who you
Fair
are.
enough.
So that's
So-
why I'm feeling disconnected here. Like I've never seen anything like this elsewhere in Kubernetes, where like you,
Okay, so no, we can actually. So let's think about this. So what we're saying is, using this users and groups. The whole problem before was what would prevent users from, say, listing all the buckets and seeing, buckets they're not supposed to. Because earlier we said through RBAC we could only allow, we could either allow users to see all buckets, list all buckets, or no buckets at all. But I'm saying that's not the case anymore. We could, there is a mechanism in RBAC where depending on where the user is coming from, whichever namespace or what their group is, they get to see some buckets and they get to see some bucket classes or bucket access class and bucket access and not others. I think there's a solution there.
Okay, so you just want to enforce the RBAC at the point when you're listing the buckets, and then the principle is if you can list the bucket, nothing's going to stop you from creating a BAR that references it and then getting a BA. That's what you're saying.
Well,
How does that resolve it? I mean, if you cannot list something, you can still refer to it, right?
Yeah,
Doesn't
right.
that's what I was going to say
from-
next. Is merely preventing the listing doesn't prevent someone from guessing or learning out of band the name.
No, referring. Let's talk about referring. So
Right.
we can prevent referral through an admission controller. That is a valid thing. Admission controller doesn't just admission controller. I mean, RBAC is used for access, but then admission controller is for weeding out things that are not supposed to go through.
Why are you trying? I'm not sure why we're trying to prevent BAR from being created. It's like counter.
No, it's not. It's not about BAR from being created. We're saying that some BARs can have invalid values. We can figure that out up front.
No, we just set them to rejected. That's fine.
Yep. The controller doesn't have to, hold, or the object doesn't have to.
It's a bad request. It's fine.
Yep.
So the proposal is when I create a BAR, if I leave the bucket name empty and I just refer to some BR in my namespace, it's going to succeed. But if I refer to a bucket directly, then it's going to go figure out if I'm allowed to refer to that bucket, and if I am,
that's allowed namespaces. It's the same as the allowed namespace proposal. There's just the location of the verification is instead of being at the creation of anything, is just in the response for the request. So that's the cozy controller. It's pretty simple for it at least to be there in the flow of the side. That's what we need. And we just need to. And we need just to say how do we what is the API for specifying who can share it, like who can get an access.
The thing that makes me nervous is this prevents like out of order creation, right? It prevents the case where I first make the BAR, then I see the access denied message, then I go fix the access, and then it binds and I'm good to go. Like now, if I request no,
I think it can work for if it doesn't exist, it can say it doesn't exist. Like it doesn't have to say rejected.
Right.
But all it can do
puts it in a state that
it's a status.
Yeah.
That's fine.
All an admission controller can do is veto the object creation or not. That's all it can do. So like
I think what it should do rather is it should append user information. That's what it should do.
Mutating webhook.
Yeah.
Mutating admission webhook or something
that
appends the user and then you want the actual bind or the actual controller to then use the information that the mutating webhook had added to go make a decision.
Right.
But where is this information?
I don't see the API guys going for this design personally. I mean,
it's dynamic. Good.
I understand.
But where do you add it to what?
Annotations
part of the spec of the object, I think.
Yeah. Or spec, yeah, sure.
But what prevents somebody else from changing it? That you will not allow it? You basically override it every time?
The bucket object. So, if admin goes and changes it, it's their fault. But, it's going to be in the bucket or the bucket access object.
Okay, and what do you get by that? You get like assignment of a verified user tag on the object. That's what you're interested in, and what do you do with that? Okay, so
you can
let's
use
say you
that for
have it.
access
What do you do with this?
So
Then later you can compare that to a list of allowed users on the bucket, and if it's and do a set membership.
But was it?
test and-
What do you mean allowed users? What do you want to
Allowed
refer
groups.
from a bucket to users?
or allowed
Directly?
groups, allowed groups perhaps, I think is what Sid was going for.
Yeah, allowed groups is what I was going for. The idea being, see, allowed namespaces is one. You know, you need to know the list of namespaces up front. It's not really.
Well, hold on. So this is
have
the
the
part of it
namespace.
that I most disagree with. Is I don't understand what problem we're trying to solve. Like, I thought allowed namespaces was fine for what it was.
Was it though?
Well,
So-
the only issue I had with it was to point out that it is the one and only security mechanism that prevents somebody from gaining access to a bucket that we don't want them to have access to. If they're able to guess the name of the bucket, and if a BAR can point directly to a bucket, then allowed namespaces is the only thing stopping someone from gaining access to a bucket. That was the point I was trying to make. But I actually like namespace as the primitive for access control. I think it's the right primitive. I don't know if a list of namespaces in some object is secure enough. That was the only concern I was trying to raise. And it seems like what we're focused on now is
here's my problem with allowed namespaces. No, see,
okay.
Here's my only problem with allowed namespaces. The traditional boundaries that existed for storage don't exist for something like buckets. A bucket is more like a node. It's like saying nodes are only allowed for certain namespaces. We don't put that abstraction for a node. We don't put that primitive on a node. It just seems like the wrong, boundary. A namespace is not the natural boundary for a bucket. Or it's not like a resource that is created and then goes away at some point. It's data, so it sticks around.
But we're not talking about the data. We're in BARs. We're just talking about access. No. I mean that it doesn't control the life cycle. It doesn't delete it. It's not about that, right? It's about providing access to some workload that obviously you want to provide access to. Otherwise, we won't be setting it up.
So isn't namespace allowed namespaces? Okay, so help me answer this. So allowed namespaces, the few problems that I see with it are, one is again, it's a static list of namespaces. Once it's set, you're stuck with it.
No, you can mutate it. We said we can mutate the B from the BR. If you have a BR, if you're a namespace or you're an admin, you just go to the B and mutate.
Yeah,
it adds these weird scenarios where if there is a namespace that is
already allowed, and then you remove it.
Yeah, you remove it, and then someone else creates it by that name.
It's an admin. If an admin does that or anything like that, we can, it can also go and.
It can also easily give access to people that they don't intend to, because the admin controls access, to some namespace. Some users get access to some namespace. Maybe not all of them should get access to.
Well, so
the bucket.
Yeah, well, we're arguing about human beings making mistakes, and I don't think that's the right way to think about security in the context of Kubernetes. I think that the important thing is that there is an access mechanism that does something, and that it fits well within the model of Kubernetes, which is based on users and groups and namespaces and accounts and all this stuff. And the reason that we were leaning towards namespaces originally is because it's such a natural way to use the Kubernetes sort of multi-tenancy model or multi-user model. Is namespaces are how everything else is segmented and divvied up. And so it's such a natural, within Kubernetes, it is the natural way to say, like, yes to this and no to that, right? Is it in the same namespace, or is it on the list of namespaces? It makes sense. I totally agree with you. Like, it's a weird way to control access to storage, but like, we don't have the luxury of like designing the optimal way of doing object storage access control, because we're doing it within Kubernetes, so we have to live within.
No, the weird part is
Kubernetes.
The weird part is that sharing is a main, it's a real use case for us. It's an important use case for us. like going across namespaces is a thing.
Right,
that
right.
we
But
have
I
to
mean,
support.
I guess the way I would like to come at this is come up with a list of what the users really want. A couple of real use cases. You know, the use case of I want to share my bucket with everyone, the use case of I want to share my bucket with no one, the use case of I want to share a bucket with this guy and not that
Specific
guy.
people. Right,
You
right.
know,
That's the part that's
right.
hard. So
For
everyone
those of
and no
you,
one is
and then the question is, can you do that with namespaces or not? And I think we just go and answer that. You know, we figure out, you know, if I do a lot of namespaces and I set it up like, you know, like this, will I get the, you know, the result I want? If yes, then it's good enough to address the use case.
namespace is probably not granular enough, but like you said, we can ask them to work around it. That might be okay.
Got a question. Did you see how EKS is working for doing the same thing? How because they have a way to allow specific pods to access specific buckets. Did you check it out?
They have. Oh, okay. I've not seen it. We should go take a look. Let me.
So
You have any background?
so
on
my point is, so I can describe quickly how they do, but my point is maybe restricting by a namespace is a good starting point. And let's go it V1, and it will be always available, and you can achieve some kind of multi-tenancy with it. But maybe later we can move towards a more, let's say, evolved model. So, for instance, EKS. So with EKS, you can bind identities to pods. And then you can typically grant temporary credentials, like STS way.
So yeah, so the way they
pods,
do bucket
yeah.
sharing is the IAM user that's bound to a pod. If that IAM user has access to the bucket, then there's access to the bucket.
Yeah. So you can bind an entity to a pod, and then you can just. So in the case of Amazon, they can just use their.
Should we? Okay.
But,
So in this case,
that model completely goes around BAs and BARs, right? That's just binding pods directly to buckets, and then the access is determined by this extra mechanism, right? Where there's no explicit granting of access in Kubernetes.
no, there is explicit granting access. You are granting that service account access to the bucket.
Right, but that's an out of scope activity, right? Like that's you go directly to S3 and say this account has access to this bucket, and Kubernetes never knows that fact. It just is true.
I mean, it's like saying Kubernetes also doesn't know that fact that bucket was actually created. It's true, right? Like,
no, but
what I'm trying to say is
with Cozy, the model is we are in charge of bucket lifecycle and bucket access lifecycle, and with this model, it sounds like we could be in charge of bucket lifecycle, but not the bucket access lifecycle, because it would be determined by something else. Right, it would just be determined by the pod and the bucket.
We would tell the backend, hey, associate this service account to this bucket with this bucket, but it's still under our control, right?
How would we do that? Like with a BAR? You create a BAR with a service account?
That was the original plan. There'll be a service account field in the BAR, and that service account would get associated with the appropriate credentials, with the appropriate, not credentials, the appropriate roles, such that any pod that uses the service account gets access to the bucket.
And then where do the creds actually come from?
There are no creds. So when a pod with a service account is associated with the bucket, S3 clients use the local metadata service. So yeah, the creds actually come from a link local IP address.
Okay, so there's like external infrastructure required for the scheme to work.
Right.
Like it doesn't feel portable in terms of I can run this on any Kubernetes cluster and it'll just work, because
that's true.
It would rely on that external service that might be present in EKS, but probably
No.
not everywhere else.
True.
I think we wanted to be really careful about designing
Supporting.
something that ties us to some external component,
Mm-hmm.
and try to design a system that is fully consistent just within Cozy and Kubernetes.
Mm-hmm.
So I think, Ben, I want to say something that I do think that we should use the namespaces as boundaries. I think it's good, but also I want to say that I think the permission model for Kubernetes is less. It's not that the namespace can do anything, right? But like the only permission model you do get is an RBAC or whatever other permission models you can use, which is just users and service accounts. Like this is the permission model for Kubernetes. If we hook into that, that will provide us with permission model. Otherwise, we're inventing some other boundary. There's this is the only thing that really permits you from doing something at the core level of it, right? We can implement our own model, of course, right? Say, have like namespaces and group them together, or have any other annotations or anything that Cozy's admission controls mutate and add some metadata for that. But the question is if we need more than just knowing which Kubernetes identity is the one that requested the access, and then we could then query Kubernetes in the same way in order to check if that identity has permission to do that, to do such operation, right? Create this BAR. But now Kubernetes doesn't allow us to really say what it can do to which one, right? Unless you start specifying specific resource names in every case there. So that's roughly where we are. We don't have the final connection so that we can check, okay, so we know who created the BAR, that's fine. It was tagged by an admission controller, but then we still need to understand how does that help us resolve the question. Does it has permission to do this request for this specific bucket? And we have allowed namespaces. That's one model to say who has that permission. That's the simplest one, right?
Well, allowed namespaces goes even further, because then you don't need to remember the user or the group that created it. You just need to know what namespace the BAR is in.
You're right.
So there's no
Right.
metadata.
It's like
necessary.
easier.
Yeah.
Right.
It seemed like
but
the
it
natural
also
thing to
it's
do.
like but it's also not very advanced. I mean, if it does get more complex in the future, then allowed namespaces will certainly be a weird API in in connection to another API that starts to do that.
Well, okay. So the simple way to enable this sharing of buckets across namespaces would be to do this, allow the BAR referred to directly to the bucket, and then have a list of allowed namespaces. And that's sort of like the minimum viable sharing design. If you say, okay, that stinks and it's not granular enough, what you could do instead is say, okay, if you want to obtain access to an existing bucket, we invent an entirely new way of doing that. Like instead of a bucket request or a bucket access request, you could have like I don't know what you would call it, an existing bucket request that lets you basically request access to a bucket that already exists and specify whatever information an access control decider would need to decide whether you get access or not. And then you could have a special object to handle this case with a special controller, and just treat it as a entirely separate case. That so in that case, BRs would be only for greenfield. BARs could continue to only refer to BRs, and then you could say for brownfield, you invent an entirely new object. It's not either of those, and specify whatever it is that the controller is going to need to make its decision. And then the sky is the limit if you do that, right? Because once you have a
how does it
way,
change? I mean, why don't we specify that in the BAR today, like in the same way, and refer to a bucket?
because once you allow BARs to refer directly to buckets, like now you have this sort of hole in your security model where, you know, if your namespace is on the bucket list, all you have, or is on the list of allowed namespaces, and you know the name of the bucket, you can always get access to it. If what you're saying is you want something more sophisticated, we could say, okay, get rid of that and say BARs always have to refer to BRs, but the way you get a BR that is bound to something that already existed is some other API mechanism, some new object that we haven't talked about yet that has whatever information you would like to use to make that decision.
But then that object is our problem. Like we need to
Yeah,
specify how that flow works anyway, right?
But I guess what I'm saying is, like, you could do that later, right? You could say 1.0 greenfield works. We don't have a brownfield answer
see.
other than admin has to do a lot of work, and then brownfield is addressed by some object in the future. That is, and that would leave open the door to making it as sophisticated as you wanted.
Right. So you're saying we can always extend it by adding another resource that represents a more complex request that we haven't thought about before, right?
In theory, yes. Yeah.
Okay, so I was just looking at how, to answer your question, I was just looking at how AWS does this little more complex form of authentication where you have a service account being related to some sort of role, and then any access coming from that service account immediately gets, if it has the role, gets access to the bucket. If not, it doesn't. So we could replicate that infrastructure in Cozy. We could have that same infrastructure in Cozy. Like since our list of protocols is actually limited, we are only working with S3, Azure, and GCS. All three have the infrastructure.
We definitely talked about that. I thought that the way that was going to work is you'd have a special bucket access class that says, bucket access equals AWS native, or I don't know, some special flag that says this is not the normal kind of bucket access class. And then if you grant yourself a BAR with that bucket access class, and then you bind a pod to it, instead of getting a normal secret and access key, it uses your service account to get access, and it just works, right? Like, we had talked about different types of bucket accesses. Like, one of them was the standard access key secret, and the other one was based on your service account. But the ones based on your service account would be necessarily cloud specific or protocol specific, and not portable, right? Because again, this Amazon magic isn't going to work in just any old Kubernetes implementation.
Yeah, about that. So we could make it work, is what I'm saying, because the mechanism for providing, the mechanism with which it works is the way an instance figures out, like when a request goes from an instance with the appropriate roles, the way it works is the S3 client on that instance looks for something called, it looks for about 7 different sources for authentication. One of them is the instance metadata, where it pings the link local IP address 169.254, and if data gets back from the link local IP address, it's not an authenticated system. If the data comes back, and if the data comes back with the instance ID or the role set to something, it just assumes that there is the right value. The client just assumes it's the right value, and then uses the credentials from that instance metadata to make requests to S3, and that's how it authorizes itself. We could. Sorry.
Is it secure? Can we use? I mean, is there any limitations to how this address is being, that nobody can be in the middle or anything like that?
Yeah, that address it's called the link local IP address because for a particular switch, it comes from the hardware days where for a particular switch you can have only one of these IP addresses, and even when going across switches, you get different servers responding to 169.254.
But is it true also when we're like, inside a container and all that, like it's not?
Yeah. So
we're
what
not
we
really.
what we would do is we would have our own controller. It'll be like, so first we would have to add some IP table rules through kubeproxy or something, which ends up routing any request from a bucket using pod to the IP address 169.2.169.2.4 to come to our controller. And our controller would know what the source IP is from which the request is coming. And based on that, it would give back data appropriate for that pod.
Okay.
And that's how we
Go ahead. So I wanted to ask, so how do you, sorry, how do you think then this, I mean, how do you describe this thing? Is it
it's called as
something that you have?
Metadata. Yeah, it's called the
No, I mean in terms of what Kubernetes is doing here in that sense, it's like we are taking over this link in terms of networking here, right? We're saying that Cozy is owning this link local address because it is being used for bucket authentication in some way, right?
Yeah. So any request coming from a bucket, pod that's using a bucket to this IP address would come to our controller, and our controller would give back some identifying information about that pod, saying that this pod's service account or this pod has these roles, or just whatever sort of information that is like it's a instance metadata is a versioned API. It's well defined. But
I wonder, do Google and Azure do the same, by the way? Is it like the same thing with their SDKs?
Yeah, Azure uses 169.2.169.4. Google uses a different IP, but yeah.
The other thing is that this is not just for bucket credentials in these environments.
Yeah, this is yeah, go ahead.
No, so I think like if we take over these, what really happens could be unexpected, right?
Well, not really. I think we would have to work with SIG Cloud to enable instance metadata. But I don't think it's not exclusively for us, like you're saying.
I'm saying that applications that use this on the cloud will not be able to use Cozy and other APIs from the cloud, right? At the same time.
It's like how we have load balancer service on the cloud. It uses the cloud version of it, but anywhere else it uses our version of it.
No, but then on the cloud, how does it use Cozy?
Oh, these things. So when you started with parameters. So when you start Kubernetes on the cloud, you start with different parameters compared to when you start Kubernetes, elsewhere.
But then how does Cozy provide credentials in the cloud?
Cozy would not provide credentials in the cloud. Inside the cloud, it would rely on the instance metadata as it always does. So if you're asking,
but if I want to run another solution, I mean, but I want to run a different bucket controller, like that's
on the cloud.
Yes.
Fair enough. Yeah, this would be a problem. I haven't thought this through that much.
I think that's kind of worries me that it's like it's the same address or well-known address that they use for other things. So maybe that's something we need to see if the SDK allows more configuration there.
I don't think so. Yeah, if it did, then we could choose a different IP address. You're right. But I don't think so. Anyways, it was worth asking that question.
What I mean is perhaps there's an environment variable which controls which IP address it uses, for example, right? Things like that would make it pretty simple to.
Yeah, it could be.
Anyway.
I mean, these things are hard coded, but yeah, I don't think. Yeah, the IP address is a hardcore. I don't think it's configurable, or at least none of the client implementations make it that way because they just expect it to be, 169.254. So yeah, I don't think going that way would be good. I'll have to verify, but I don't think going that way would be good.
Okay.
Yeah. Yeah. It was worth asking this question. The question was basically, what if we built the same infrastructure that would be there provided by the cloud for the service account-based authentication? It looks like that also might be, well, in terms of implementation, it is very difficult because we'd have to
I
coordinate.
don't think
with
we're
the-
missing infrastructure to. I don't think we have any infrastructure missing. Like it's just that there is like Kubernetes is not providing us with a formatted capability to provide access to these resources for reference, right? It doesn't allow us to run that, but we can. So we need to define our own model, regardless of how we actually validate. The validation, I think, is we're going to validate and then give that pod credentials, and it's fine. It's going to work.
I
But
see.
we're missing the model that we rely on to decide whether somebody has access to a bucket, right? Can get bucket access, basically.
Yeah,
And if it's
exactly.
allowed, I mean, we haven't closed on it. I mean, we can always say it's a list of namespaces and that's it, right? But
And I don't have a big problem with the list of namespaces. I want to be clear about that. It's very
Yeah.
easy to implement, and it's way better than not having a brownfield story at all. The only reservation I have is that, like, once we put it in, it would be hard to take it out if we had a better idea. But like in the absence of a better idea, I think it's good.
I think it's a good default way of doing it. At least there is something, right? And
the only question I would say is, like, if we need to prepare the structure to be, like maybe like a role spec or anything like that, other than just being a list of something fixed. That's a list of namespaces, or should we say it's a list of API of things, right? That we can refer to from a bucket. Like it's a list of service accounts, or it's a list of I don't know, pods. I mean, I'm just thinking for extensibility of what we're the CRD that we're defining.
Based on the design we have today, the only time this would be consulted is when you have a BAR and you're deciding whether to create a BA or not. You would look at this thing. So no pod has been created yet. You don't know the user who created the BAR necessarily. You just know that there is a BAR in a namespace. You're deciding whether to create a BA or not. And if you create a BA, the act of doing that is going to involve going to the driver and minting a credential and storing it in the BA. And then from that time on, any pod that uses that BAR will just get the credential and run with it. And like no service accounts are going to enter into the picture. No tokens are going to enter into the picture. It's, because you have a credential, it's created, it's in the database, you're going to use it. But that's the model we have for BARs and BAs today. Is you when the BAR gets created, you make a decision whether to create the BA or not, and once you do, you're done. There's no more security decisions to be made.
I'm not suggesting today we do it, but like so I think for today we actually want this list to contain only namespaces, but maybe in the form of referring to to an API object, like just like the spec of like the role spec does. But going forward, it could be that the pod permission could be to mount that BAR, right? It could affect it. Anyway, I don't know. I'm just thinking if it makes more sense as a structure.
Any pod in a given namespace can use any BAR in a given namespace. But we haven't said anything.
I'm talking about the future. I'm not saying that it's relevant today for like getting to this fine grain. I don't think I know if it's ever relevant, but I'm just saying that in terms of if I want to say to who I'm giving permission to do something, perhaps it's more complex than just saying it's a namespace. That's the only thing I'm
I feel like if
making
we ever
like in
did
the
extend
future.
it, if we ever did extend it, it would have to be backwards compatible to what we already have. And that means namespaces would have to continue to work. Even
Yeah.
if we,
I mean, we're still alpha.
Yeah. So
that's true. If it's alpha, you can totally change it and just
Yeah.
apologize.
But
you have a better idea.
it's still okay. I mean, if we still support, like, it's in the same way as you have in roles, right? You have who, like, what can this do? And everything is additive. So if a namespace appears there, the namespace can get it, right? I'm not, well, anyway, I agree that it's not well known how this works if we extend it, but
there are at least two use cases of, I would say, Kubernetes. Either you work directly on the platform. Typically, it's a big data platform. It's shared by multiple people, and then the namespace approach is good, right? Because typically you put all your tools in a specific namespace, and users don't have access, and you just give access to groups or to individual people in specific namespaces, and you create bucket for them for doing whatever analytics or whatever computations. The other use case is when you use Kubernetes as a platform for running your own service, and then in this case you don't give access to people individually. They are you just operate a system in Kubernetes, and in this case you don't need fine-grained access because it's managed by the software you are deploying on Kubernetes. So
we might not need it today, but I'm just
you see what I mean. You either
no,
you
it's true that we don't need it, right? We're saying that MVP can run without more granular access permissions, but you probably have seen that all the cloud providers have very, very fine-grained access permissions. So you get to a point where this is getting more complex as you manage bigger clusters.
They did it freestyle, right? They did not consult anybody. They just they took
the cloud providers.
Yeah, they integrated Kubernetes because they had to, and then they said, "Oh, that would be cool to integrate with our own IAM system." And
they have a totally different set of constraints. They're not aiming for portability or anything. They're just aiming for maximum functionality in their own walled garden.
See, we don't want to come up with a system where the user goes and does credentials on their own.
What does that mean? You mean you enter your own access key and secret?
Yeah. Instead of going through our system. I mean, then we've done it wrong at that point. We've failed them. My question is coming from the point that just trying to answer. I don't know the answer. I'm not. It's not a loaded question. Is there? Do you predict that people will be fine with our non-granular access control?
You're calling namespace non-granular?
Well, yeah,
I think they will.
Yeah.
Yeah.
I think so too.
Given that everything else is going to boil down to namespace granular access control. I mean, because once the BAR exists, then any pod in the namespace can use the BAR. So it's like, it's effectively going to be namespace granular, right? Because regardless of how you compute whether a given BAR combined to a B, once the BAR is created, anyone in the namespace can use it.
No, but I don't think that's correct exactly. I mean, to say that anyone can use it. It's not like a code running inside a pod can then just go and decide to do that, right?
Well, the way that we've defined the CSI plugin that's going to inject the credentials into the pod is if there's a BAR, and if that BAR is bound such that it has an access key and a secret, and if the pod refers to the BAR, it's definitely going to get the access key and the secret. Nothing's going to stop that from happening.
But it has to be, I mean, it's not that anybody, like in the sense that any code running within a namespace is really exposed to the credentials. If I didn't create a pod and have a reference to a BAR in a namespace as the one that's deploying the workload, right? then it's not there. There is no link for that pod to read the credentials.
But anyone who can create a pod and see the BAR can in principle get those credentials out, right? Because all you have to do is write a little pod that binds to the BAR and exfiltrates the access key and the
Yes.
secret at the moment it starts up. And
You mean
you're done.
if you have that permission to create Kubernetes
create a
API
pod.
objects in the namespace? Yeah,
Yes,
of course. So
yes,
if you
yes.
can create a pod, right?
Right, but
Right.
the point is the namespace is the barrier. Like either you're in the namespace and you can create pods, or you're not and you can't. There's no subdividing.
Yeah.
True. Fair enough. So you're saying it doesn't matter even if you have granular access, you still get full access through the namespace.
I'm saying as long as we're going with the BAR, BA bound objects way of doing access control, then yes, you're basically forced to operate in a namespace granularity, because that's just how everything else works.
Okay, can we do this then? Okay, so let's do this. Ben, I think I'm on the same boat as you. Maybe allowed namespaces is all we've got. Can we at least clearly define what are the limitations and move on with this conversation? Because I feel like we've spent enough time. I'm not entirely sure there is a simple, better approach.
Okay, so what we need to write down is things like, how do you get all the namespaces, right? If you want to get the wildcard, is there a way to do that or not? Can you have an empty list so no one has access? We have to define what does it mean.
Selector.
So something other than a literal list of namespaces. We have to decide, do we want to allow that, or just have it be a list, or maybe the one wildcard I think we need is all, right? That you need to have a way of saying, you know what, anybody in the cluster can just use this, because I don't want to prevent
no one.
Right, but we need to write down what happens when you mutate the list to remove a namespace that has a bound BAR, and my humble recommendation would be, that's fine. Once it's bound, it's same thing as a storage class. If you delete a storage class after you have a PVC, it doesn't affect the PVC because you only looked at the storage class at the moment of creation. After it's created, you don't look at it anymore. So we could say after a BAR binds to a BA, we never look at that list of allowed namespaces again. So if you really want to revoke access, you not only have to change the list of allowed namespaces, you have to go delete all the BAs that you don't like as a separate operation.
Right, and we talked about revoking quite a while, so I think we.
Yeah. So I think as long as we write down that kind of stuff, and then we can say, and in principle, anyone is welcome to write a controller that auto mutates this list based on some rules, and we don't care how you do that, right? Because it's, as far as we're concerned, it's just a list. And then we're done.
Okay, so are we still going with the list, or are we going with selector?
Well, I don't know how you write a selector that degenerates into a list.
No, it doesn't have to, right? Like if the namespace is selected by the selector, then that namespace is allowed.
Right, but if I just want to say Alice and Bob and Charlie and nobody else, like how do I write a selector that means that?
Yeah, it's better to have one namespace per group, and then you edit the bucket class and you add all the groups you want.
But we're talking about after the bucket is already created. I want to now grant access to 3 namespaces and no others.
So, by the way, what happens if you edit the bucket class?
It doesn't do anything after the bucket is created. You only look at the bucket class at the moment you're provisioning a new bucket. Once the bucket is provisioned, you can delete the bucket class and the system doesn't care.
Yeah, okay. So there is no way to revoke or to change or what?
Well, the way you revoke is you go directly to the bucket and edit the bucket.
Okay.
Well, no, you still don't revoke it. No, you revoke it. You can revoke access for a particular pod by deleting a BA. You don't revoke access to a BA that that's been provided access to.
I mean, you can revoke the permission to bind new BARs by editing the bucket, right? If you want to revoke existing BAs, you have to go delete the BAs.
Right. And here's the other thing. Allowed namespaces, if it was a selector, if you wanted to give access to new namespaces, add the selected labels to the new namespaces.
But it's pretty simple. We also said that
requires admin access, right? It's
Right.
Yeah,
required
yeah,
to
only
do-
admin can do. Yeah, that's fine, right?
So that's good. That's the
Yeah.
reason why it works.
Yeah.
No, but I mean, it's
Let's say
undesirable.
you have a
because
label, like two labels, right? The good ones and the bad ones. Okay. And
it-
only the admin can set it, right?
if I want to write a controller whose job it is to automatically mutate this list, I shouldn't have to give it access to edit everyone's namespace, because that's pretty high access.
But only namespace objects.
Still, I mean, if I need to grant edit access or modify, I think it's called modify, to every namespace in the system, just so that this controller is able to administer which namespaces can access which buckets, that's a pretty high level of access.
So you're saying it's better to mutate the list of accessible namespaces rather than to go update the namespaces themselves?
That's my intuition, yeah, is to centralize where the edits happen to the bucket itself.
Isn't that kind of okay? So with